Good morning, guys. I hope you're doing well today. Today we're going to be color coding the periodic table. So each of you should have received a half sheet with this periodic table on it. You're going to need a set of colored pencils or pens. And when we go through and color code, what we're trying to do is to identify some of the major groups and the major trends on the periodic table. So we're going to be splitting it up into metals, nonmetals, metalloids, which elements are solids, liquids, and gases. And then we're going to be grouping the families on the periodic table as well. So first thing I want you to do is you see this dark line right here that I've drawn on my periodic table. I want you to go ahead and draw that line on your table. If you need to pause this video and take a second to draw that, go ahead and do that now. When you're finished with that, the first thing we're going to do is we're going to first thing we're going to do is draw in the corners of the boxes, and we're going to separate the metals, the solids, liquids, and gases. So most of the elements, and you should know this from your notes, exist as solids at room temperature, but there are a few that are gases and liquids. So we're going to take a red pencil, pen, or marker, and we're going to draw dots in all of the boxes and all of the elements that are gases at room temperature. So those gases are nitrogen, oxygen, fluorine, chlorine, and then everything in group 8. So they're called the noble gases for a reason. We've got helium, neon, argon, krypton, xenon, and radon. And we're going to leave out 118 for now because we're not sure about that one yet. It's a brand new element. We haven't really gotten a chance to test. Last one we need to add in there, coming over to this side of the table, is hydrogen. Alright, so everything with a red dot is a gas at room temperature. We're going to do the liquids next. So for our liquids, we've only got 4 elements on the whole table that are liquids at room temperature. So those liquids are number 35, bromine. We're going to put a blue dot on those. So bromine gets a blue dot. We're going to come down to number 80, mercury. Mercury is actually a metal that's liquid at room temperature. And then last two are 95 and 96. Americium and curium, those both get blue dots. So as you can see, we've got a few gases, we've got a handful of liquids, but most of our elements are going to be solids at room temperature. So everything else on this table gets a black dot. So everything that doesn't have a dot of another color gets a black dot in the corner. It's going to take a second. While you're working on this, start finding or thinking about finding a green, yellow, and orange pen, pencil, or marker. We're going to be outlining our boxes next. Alright, before I move on to outlining my boxes, I want to make a key down at the bottom that tells me what these dots mean. So when I come back later and look at this table, maybe on a test or a quiz, I can actually read it. So red dot is gas, blue dot is liquid, and black dot is a solid. Okay, so I've got my key, I've got all my boxes dotted. Next thing I'm going to do is come through and outline my boxes. So when I outline my boxes, what I'm looking for is this element a metal, a non-metal, or a metalloid? We're going to start with the metalloids because there are not very many of them. So when we look at this dark line that I had you draw, basically everything that touches that line except for aluminum is going to be a metalloid. So I'm going to take my orange pencil marker or pen and I'm going to draw the outline of the box in orange. So I'm just going to go down this staircase. And everything that I outline orange, you should outline orange as well. Okay, so we've got boron. Oops, I should not have outlined aluminum. We'll go over that in a second. Got carried away. We've got boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. These should all be outlined in orange. And they all come down that staircase. Okay, let's do our non-metals next. For these you're going to need a yellow pen, marker, or pencil. So as we've said before, pretty much everything to the right of the metalloids is going to be a non-metal plus hydrogen. So let's start with hydrogen. Gets a yellow outline because it is a non-metal. And then for these other non-metals, I think I'm going to do them as one big block instead of outlining every single one. You can outline every single one if you want, but for me it's easier this way. Okay, we're going to leave these two guys at the bottom, UUS and UUO. They are newly discovered, so we don't know much about them yet, so we're not sure what they are yet. So we're just going to leave them alone. We'll leave those blank. Okay, so I've got metalloids, I've got metals, I've got a green pen, pencil, or marker. So the last group I'm going to do, you can probably guess this, is going to be my metals. And that's pretty much everything to the left of the metalloids except hydrogen. And these guys down at the bottom. These guys at the bottom, they're labeled lanthanide and actinide. They're actually inner transition metals. They fit in right here, but to keep it from getting really stretched out, we just sort of crop them out and put them down at the bottom. So they're still metals. So again, for me, and you can outline every box if you want to, but for me, I'm just going to outline them as a group. And I'm going to be sure to include aluminum in that because I should not have colored that orange. I'm going to leave those two mystery guys at the end. Alright, so once more down here at the bottom, I'm going to make my key so I can tell what those colors mean when I come and look back at this later. Green for metals, orange for metalloids, yellow for nonmetals. Alright, so the last step on this one, you're going to need a lot of colors for this. So these are all of the pencils that I have for this step. I've got orange, yellow, pink, we've got a light blue, sort of a red-orange, light or dark green, dark blue, light green, red, and brown. Take a second to find all of those pencils. I'm going to repeat them. We've got brown, red, light green, dark blue, dark green, red-orange, light blue, pink, yellow, and orange. Take a second, maybe pause the video and find those pencils. Once you've found those pencils, we're going to start in on the families. We're going to color all of the elements of a family together. First one we'll do is hydrogen, and hydrogen is going to be white, so I'm not even going to touch that box. So down here at the bottom, I'm going to start my key for families. I'm going to mark that hydrogen was white. Alright, we're going to start on the left and work our way over. So hydrogen was white. My next family is going to be my alkali metals, so I'm starting with group 1 on the left. Hydrogen is in group 1, but it's not an alkali metal because it's not a metal. So everything below hydrogen, from lithium down to francium, is an alkali metal. What I'm going to do is I'm just going to lightly shade all of those elements yellow. A couple of things about the alkali metals. We know they have one valence electron because they are in group 1. We know that they are very, very reactive. They love to make bonds with other atoms. And we know that they're extremely violently reactive when you put them in water, when you put big amounts of pure alkali metals in water. So hopefully, I'll write this nice and dark so I can read it later. Alkali metals were yellow. My next family, excuse me, is going to be my alkali earth metals. Somebody has taken my purple pencil. You're going to need a purple one as well. Give me 1 second. So your alkali earth metals are going to be group number 2. Excuse me. And they're going to be purple. So you do need a purple pencil. We're going to go ahead and lightly shade in everything in group 2, so from beryllium all the way down to radium. Just lightly, neatly shading in those boxes. We want to stay inside the lines. We don't want to make our families blend together. Just keeping them to themselves. So hopefully you remember from your notes, group 2, the alkaline earth metals. They have 2 valence electrons. They are group number 2. And they're very important for living things. Things like calcium you need for strong bones. Even strontium can be found in your teeth in small amounts. Magnesium helps your muscles. So down here on my key, I'm going to do alkaline earth metals, and those were purple. Next up is the transition metals. Transition metals I'm going to color orange, and they are everything from group 3 to group 12, minus these 2 boxes. I'm going to leave them out. So I'm going to draw a little line to remind myself not to color those. So everything else in this sort of dropped down group from 3 to 12 is a transition metal. So we're going to color them orange. Transition metals we don't really talk about in this class very much, partly because they don't really follow the same rules for valence electrons that our other groups do. So we said for groups 1 and groups 2, easy to remember how many valence electrons because it's the same as their group number. That's not true for the transition metals. Some transition metals, like iron, can have more than one state for bonding. It actually gets a little bit complicated, so we're going to know the name for this group, but I don't need you to know really anything else about them right now. So just know that these guys that I'm coloring orange, this whole big group, are the transition metals. Still recovering a little bit from being sick, so I apologize. My voice in this video is a little scratchy. Alright, coming all the way across to the end of group 12, just shading nice and lightly and neatly. Get mercury in there, and we're good. We're going to add that to our key. Those were orange. Alright, next up, we're going to, let's go ahead and do the lanthanides and actinides. So you're going to need green and red-orange for these two guys. We're going to do the lanthanides first. So remember I said lanthanide, they're labeled right here. It's everything across this row is the lanthanide series. And like I said, these actually fit right up here. So if you took this box, took this whole row and fit it in there and just stretched everything out, that's where the lanthanides belong. But that's really hard to fit on a poster, so we cut them out and put them at the bottom. So everything in this row is going to get colored dark green. Save your light green pencil for later. The lanthanides are going to be dark green. And these guys are still metals. The lanthanides and actinides together are sometimes called the inner transition metals because they fit inside the transition metals. So we color those dark green, and then we're going to come up here to this box that says 57 to 71. We're going to color that green too because that's where they actually fit in. We just moved them. Alright, so actinides, lanthanides. Got ahead of myself there. Are green. Okay, next you're going to need red-orange. So we're going to come down to the row right below to the actinides. Like I said, got ahead of myself. And those are going to be red-orange. Again, nice and light and neat shading. Stay inside the lines. It's the actinides you start getting a lot more of your man-made elements. So we've got neptunium and plutonium. If you remember from our video a couple of weeks ago, those were created in a laboratory. They're not really found in nature. So a lot of your actinides are man-made rather than natural elements. So we've got that entire row shaded red-orange, coming up to this box that says 89 to 103, coloring that red-orange as well. Alright, and then looks like I need to scoot my key over a little bit. Actinides, or red-orange. Okay, now we're going to work our way to the right side of the table. Our boron family is going to be dark blue. I know that looks black, it's actually blue. So when I say boron family, I mean group 13, everything starting at boron, coming all the way down to our newly discovered element 113. So all these guys down here that have these three-letter names, those just mean they haven't been officially named yet. They're just filler names. So everything from boron down, aluminum, gallium, indium, thallium, those are all going to be dark blue. And while we're at it, we'll include 113. Since it is in the same family, because it's in the same column. Alright, so dark blue was my boron family. My carbon family, group 14, I'm going to take my red pencil and color everything from carbon on down. So trying to keep it nice, trying to keep it neat, trying to keep it light. Get it all the way shaded in. Okay, so carbon family is red. Next up, we're going to do light blue. Light blue is going to be our nitrogen family, group 15. So starting with number 7, nitrogen, coloring all the way down to the bottom. And just as a quick check, if it's group 15, I want you to guess how many valence electrons this group is going to have. I should have done this pencil for dark blue. Hopefully, remember from your video notes earlier, if it's group 15, that gives me a clue to how many valence electrons it has. It should have 5 valence electrons, because I just take away the 1 in front of the group number. And that works for groups 13 to 18. For groups 1 and 2, the group number is the number of valence electrons. And then for the transition metals, we're going to ignore them, because they have multiple states. I'm not going to quiz you on the transition metals at all. Alright, oxygen family. We need our brown pencil. So the oxygen family is sometimes called the chalcogens, if you ever hear me use that word. I'm going to leave this nice and light so we can see the words underneath. So oxygen, sulfur, selenium, tellurium, polonium. Polonium was discovered by Marie Curie. Some of you might remember that from your projects. Okay, so oxygen, nice and light. Oxygen FAM. I have to start abbreviating and running out of room. Alright, 2 left. You should have a pink pencil and a light green pencil left. We're going to use the pink pencil first. Pink pencil is going to be group 17, and those have a special name. I want you to try and see if you can remember what that special name is. Give you 5 seconds. So this family is the halogens, and I do need you to know that name. So whenever you see group 17, which starts with fluorine, I want you to know that's a halogen. And group 17 has 7 valence electrons. Remember, happy atoms try and get to 8, so group 17 atoms are almost there. They're really trying to fill up those shells, so they're also very reactive, just like the alkali metals. They love to bond with alkali metals. Alright, halogens are going to be pink. And then last one, group 18 on the far side, those are going to be your noble gases. So we're going to start at helium, go all the way down. So noble gases don't like to bond with anything. Why do you think that is? You might remember noble gases have 8 valence electrons. Remember, happy atoms have 8 valence electrons. The point of bonding between atoms is to try and fill up their shells. So if a noble gas already has a full shell of valence electrons, it doesn't want to bond with anything. It doesn't want to give any away. It doesn't want to get any extra. It's just happy as it is. So these atoms generally don't bond with other things. Okay? So noble gases. Try and make that a little neater. Noble gases. E green. Okay? So just to check that you have everything that you need, all of your gases over here and over here should have a red dot. Your 4 liquids should have blue dots. Everything else has a black dot. You should have labeled that at the bottom. Red for gas, blue for liquid, black for solids. Our metals are outlined in green. You could have gone through and labeled each box individually or done them as a group like I did. Your metalloids should be outlined in orange. Remember, I made a mistake. Aluminum's not a metalloid. Just got carried away there. And then your nonmetals are outlined in yellow. Don't forget about hydrogen. Your families, hydrogen, should have been left white. Alkali metals are yellow. Alkaline earth metals are purple. All of my transition metals are orange. My lanthanide series is dark green. My actinide series is red-orange. My boron family was dark blue. Carbon family was red. Nitrogen family was light blue. Oxygen family was brown, or chalcogen was brown. Halogens were pink. And then finally, we had light green for all of our noble gases. If you have any questions about this project at any point during the video or after, please let me know, either in class or by email later. Make sure that you hold on to this table, and then before you do anything else, I want you to come up to the top and put your name and class period on it. Okay, name and class period up at the top. Alright, see you guys later.